The internet is like a huge network of computers all talking to each other. To make sure that information is sent and received accurately and efficiently, we use two protocols called TCP and UDP. These protocols determine how the information is packaged and sent over the network. Let's look at how they work. TCP stands for Transmission Control Protocol. It's a reliable protocol that ensures that all the data that is sent is received correctly and in the same order it was sent. It does this by creating a virtual connection between the sender and receiver and checking the data for errors. The data is divided into small packets and each packet is given a unique number. The receiver sends an acknowledgement message back to the sender for every packet received correctly. If the sender doesn't receive an acknowledgement within a certain time frame, it assumes that the packet was lost and retransmits the packet. This process continues until all the packets are received correctly. UDP stands for User Datagram Protocol. It's a fast protocol that sends the data without any error checking or guarantees that the data will be received in the same order it was sent. The data is also divided into small packets, but unlike TCP, there are no unique numbers or acknowledgement messages. The data is simply sent from the sender to the receiver as quickly as possible. Because of the lack of error checking, some data may be lost or received out of order, but it also means that the data is sent and received much faster. So, as you can see, TCP and UDP work differently to ensure that data is sent and received accurately and efficiently. While TCP uses a virtual connection, error checking, and retransmission to ensure reliable data transmission, UDP uses speed as its main priority and does not use error checking or retransmission. TCP provides error recovery, but to do so, it consumes more bandwidth and uses more processing cycles than UDP. TCP and UDP rely on IP for end-to-end delivery. TCP is concerned with providing services to the applications of the sending and receiving computers. To provide all these services, TCP uses a variety of fields in its header. The TCP header includes several fields, including source port, specifies the port number of the sender. Destination port, specifies the port number of the receiver. Sequence number, identifies the first data byte in the current segment. Acknowledgement number, confirms that the receiver has received all the data up to this point. Data offset, indicates the size of the TCP header. Flags, contains various control bits, including assign, fin, RSD, PDISH, ACK, and URG. Window, specifies the size of the receive window, which controls the amount of data that can be sent before the receiver must send an acknowledgement. Checksum, verifies the integrity of the header and data. Urgent pointer, specifies the offset to the urgent data, if any. Thank you for watching. If you enjoyed this video, make sure to check out the rest of our CCNA course series, all available for free. Follow us on social media to stay updated and be a part of the community. And don't forget to hit the subscribe button and turn on notifications so you never miss a video. See you in the next video. Until next time, farewell and happy studying.